Hi everyone, welcome to Learn with me. Let's continue our journey with LeetCode 75 today. So, we did a question with hash map or set, rather with queue. Let's try to do another array string problem today. Let me change it to Java. This question seems to have a short description. Let's see what this is all about. Great common divisors of strings. Okay, that's interesting. For two strings, we say T divides S if and only if S equal to concatenation of T. All right. So given two strings, return the largest string such that X divides both str1 and str2. Wow. I'm not sure if this is easy. First, let's try to see the different examples and see if we can see any patterns. Right. Before that, let's try to understand the greatest common divisor concept for numbers. I feel this will help us to decide the pattern, so that's why indulge me here. So let's say 10 and 5 are two numbers. 1 can divide 10, 2 can divide 10. So 10 divided by 2 is 5 without any remainder. That's why we say it can divide, because the remainder is 0. 3 cannot. 4, nope. 5, yes. 6, 7, 8, 9, and 10. So these are all the divisors of 10. What about, let me write here, divisors. This is for 10. And then for 5, 1 can divide 5, 2 cannot, 3, 4, 5, 5 can for 5. So 1 is a common divisor for 10 and 5. The next common divisor is 5. And the greatest number out of that is 5. So 5 is the greatest common divisor for 10 and 5. So let's say two numbers such as 2 and 3. So for 2 and 3, 1 can divide 2, 2 can divide 2. For 3, 1 can divide 3, 2 cannot, and 3 can. So if you see here, the greatest common divisor is 1. So let's just have this in the back of our mind and then come back to the strings here. And so the first example that was given to us is ABC, ABC. And the next string given to us is ABC. Now first, what they are saying is any string, if you can concatenate it to create the other string, T is set to divide S. So that is the definition for division. So if you see here, let's say if I take a string T equal to A and I concatenate it this way. So I know S is of length 3. So I'll just take this 3 times and see what I'll get. It will be AAA. It is not ABC. So that's why T cannot divide S. What about B? Similarly, it will be BBB. It's not same as ABC. So clearly we can see that T a string of length L, where L equal to 1, and the options we have here are ABC. We are not going to get S by just using one specific letter. Let's consider T which is of length 2. For example, here let's take AB, since we see that pattern in S. If I do AB, and then even if I repeat it a second time, I will get AB and AB. So already the length is 4 and S is of length 3. So clearly if I repeat a string which is of length 2, I'm not going to get S. Okay, so let's consider a length of 3, and let's use the first 3 letters as the pattern. So clearly T is already same as S, so T divides S. So looks like the only string that divides S in this case would be S, right? We are also told here that both the strings will consist of English upper letters only. So the options we need to choose from are A, B, C, so on till Z, and then AB, AC, and so on till, whatever the last combination would be, maybe. So there will be a lot of such combinations. And the last one will be the length of S. So all combinations up to the length of S we need to check. So clearly from this example, so we just saw for ABC, right? So the divisor for ABC is T. What about for string 1? String 1, the divisor would be, we can see here without going through all the patterns, that T equal to ABC will work. It will, if I repeat it twice, so ABC plus ABC will be ABC, ABC. So this is a divisor for this S, and the next possible one is T equal to ABC, ABC only. Anything in between that is not going to work. So if I look at this string ABC and this string, that is string 1 and string 2, the greatest common divisor would be ABC, right? That's quite interesting. Let's see the next example. So string 1 equal to ABA. Okay, let me change it to capital AB, AB and AB. So let's see the divisors of these. So divisors are any string that when you repeat it, you should get the string 1. So we can see that if I repeat AB multiple times, that is 3 times, I will get string 1. If I repeat ABA, again I won't get this string. If I repeat ABAB, I won't get this string again because it will be more than the length. So the final one possible is the string 1 itself. What about string 2? So the divisors for string 2 are, so it's not A. What about AB? Yes, AB is, if I repeat again, I'll get this string. If I repeat ABA, there will be 3 more letters, so it will be greater than string 2 length. It's not the same. Then the final one is ABAB. So if you look at this and this, the string which has the highest length is AB, which is common to both of them. So the answer is AB. Right. Looks like you're starting to say something, or maybe not. Let's see the final example here. So leet is string 1 and code is string 2. So what are the divisors of leet? Can I repeat L? I'm not going to get leet. LE, nope, nope. So the only divisor is this, and for code, the only divisor is code. So there is no common divisor, and you can say that the space, or rather spaces, when you don't have any common divisor, or you consider that to be the common one, and you just send that out as the output. Just with these examples, there are some observations that we can make, right? One, though we can form so many different combinations of the English letters, we just don't need to go through all of that. We just need to use the letters within the existing string and figure out whether there are any divisors, what are the common divisors, and so on. So that is one observation. I don't need, definitely if I use Z or D, I'm not going to get this string. So I don't need to check that basically. So that is one observation. The next observation is we don't need to look at patterns which are not part of the string. For example, AC, I need not check if it is a divisor at all because AC is not there in the string. So I need to check a pattern which is already there in the string. That's all. So that is the second point. So check for letters in the string, check only for the patterns in the string. These are two observations. Also, if you see, you start from the beginning and you can start looking at different combinations starting from the beginning. So of length 1, length 2. So I know there is a pattern BC here, but it's clearly not the pattern from the beginning. I don't need to look into it because I already know that if I start from BC and continue with BC, I'm going to get this. I'm not going to get ABC. So this is already known. So you don't have to check for patterns which are in between like CAB and so on. You just start for the patterns which are starting from the beginning. So check for patterns from the beginning only, right? This is another observation. Well, I said beginning, but right from the end also works. Let's not confuse ourselves too much. So let's just say, so from the beginning, if you check for the patterns, it is sufficient. So what other observations can we make here? And well, the divisor of the longest length will be the word, will be that string itself. So greatest divisor for a string will be the string itself. That's another observation. What else can we make here? We can stop looking at the patterns after, half length is reached, right? Because if the length exceeds half of it, when you double that length to concatenate, it will be greater than the existing string. So what I'm saying is, let's say I want to see if ABCA is a divisor of S. It can never be the divisor of S, because if I repeat it again, ABCA, ABCA, this length is already greater than this length, so it's definitely not going to be the same as this string, and so it cannot be a divisor. So check for patterns from the beginning only and stop once you reach the mid length. What is the mid length? If it is even length string, it would be, say, the length divided by 2. If it is an odd length string, then it would be length divided by 2 plus 1, because for integer division it will be 3 by 2 equal to 1, and then you can check, I'm sorry, I think divided by 2 is sufficient, because if I do plus 1, then it will again exceed, right? So stop once you reach the mid length. Use integer division by 2. So what other patterns can we figure out here? Also, the question here asks for the greatest common divisor. So it makes sense to start from, of a higher length than the lower length. So what it means is, let's say I have AB, AB, AB as one, let me increase it. So ABC, ABC, ABC. Let's say this is string 1. And, well, I'm changing a string again. Changed my mind. So ABC, ABC, A. So let me consider another string which looks like this. Now, the greatest common divisor of both would be this. So I don't have to start searching for the smaller strings. Once I know the longest length one, then we should be good. So that will reduce our search. And then we don't have to check for all the patterns within the string too, because they just said check if what is common between these two. So we can take kind of the smaller length string, or if it is equal length, we can just take any one of them and then see if there are any common patterns. And that should give us the idea. That seems doable. So let us see what this code might look like. Say, find the smaller string out of string 1 and string 2. If same length, choose one, choose any one basically. Then find what, so the next thing we said is we look for patterns from the beginning only and stop when we reach the mid length. So find what is the mid length of the larger string, and then we need to wait a minute. So we find what is the mid length of the larger string. So in this example, we will check if what is the length, like mid length of this, that will be 3. Now does it make sense? Well, first we need to know if that is a divisor, if there is a divisor of length 3 for the other string, right? Well, it needs to divide both. That is interesting. Let me take a step back. This seems to go a bit complex. So before doing this, just so that we understand what's going on, this might be helpful later on, so I'll just leave it out. So I'll scratch it out for the time being. I think what might be more simpler is find all the divisors of string 1. How do we do that? Well, we know string 1 is its own divisor. I will leave that out. Then we know that we can stop with the mid length, so we will start from there. So find the mid length of string 1, which let's say equal to mid. Then check if repeating the pattern, which is from beginning of string 1 till mid length, if this is a divisor. Check if repeating the pattern, which is from beginning of string 1 till mid length, which is a divisor, or in other words, creates string 1. And continue to do A and B. Well, let me take a step back. Not A and B. I will make it more specific. So once we find whether it creates string 1, what should we do? Should we keep it somewhere in a list, perhaps? Let's say we will keep it in a set. Add the divisor to a new set called divisors 1. Then what we need to do, we will reduce the length by 1 from mid, basically. So if the length was 3, now we'll say length is 3 minus 1. And then we again check B and C. Do B and C till length is 0. We continue this process. And I think in B, what we need to know, if whatever length we have, first of all, does it divide the length of string 1? So check if string 1 dot length is divisible by mid. If so, repeat the pattern same number of times as the dividend, and the pattern here is this. Okay, I'm not able to see that. Okay. The pattern equal to from the beginning of string 1 till mid length, and then same number of times as the dividend, we are going to repeat it, and then Let's say if it creates string 1, then it is a divisor, otherwise it is not. Add the divisor to a new set called divisors1, reduce the length by 1, and then continue this process. So do that for string 1, then do the same for string 2. Find the common strings in divisor 1 set and divisors 2 set. After you find the common ones, find the string with the highest or longest length, which will be the answer. Well, if you don't have anything common, then if there are no common strings, then answer is space. So this is something which we can understand logically, though there can definitely be something which is simpler. Let's try to do this first. Let's ask ChatGPT. We have, I asked it something simple, what it will be able to assist us in Java. I hope it understood what I said. So let's first take this and paste it here. I'll remove all the examples. I should probably use the notes instead of typing it here, right? Or use comments. Anyway, so find the divisors. So for that, basically they created ChatGPT created 2 sets, and then says retain all. There is a retain all function, quite interesting. And then you see the longest common divisor. So once you retain all the common ones in divisor 1, you see what is the highest length, and then you just return it. Now before that, I think, is there extra space? Oh my god, there are some. Let me format it. Oh my god, I forgot about this, so I'll have to remove all of this now. Or I can comment it out. Well. Yep. So now we need to get the other method, which is the find divisors. So nice modular methods we have here. Let's just make it private and not formatted. Don't have static, it's within the solution class, so I can just have it this way. Find divisors, what does it do? So we asked it to, well, create a new set. The length starts from here. The initial one is mid length divided by 2, and then you go on reducing it till it is greater than equal to 1. If the length of the string is divisible by mid, then you do something, which is check if repeating the substring creates the original string. So first we'll find the pattern starting from the beginning to the variable mid. Then we will repeat the pattern the same number of times as the dividend, which is length divided by mid, and then we will check if it is equal. If it is equal, we add it to the divisors. So the logic looks correct, whatever it's doing exactly what we asked it to do. This can definitely doesn't look like a solution that is feasible. So where is the run button? So many things seem to be, here it is. Where was that hiding? Oh, okay. So what did I miss? 1, 2. Oh, okay, forgot that. So let's just format it again, and then something is definitely wrong here. So one thing we missed here is we didn't include the string itself in divisor. So the string itself is its own divisor. We saw that. So divisors.add str. Now should look good. So all the cases are working. This logic should work, but it would be slow. Well, unless we are missing some edge case. Okay. So you see it beats just 9%. That means it's a very slow solution. We are doing a lot of extra work here, right? So let's see now, how can we reduce it? So the extra work is finding all the divisors separately. Whereas we need to know what is common among them, right? So one simple thing we can do to begin with is we find what is the string of the smaller length, find its divisors, then check if they are the divisors of the longer one. If yes, then we proceed, otherwise we say it is blank. So I will change the pseudocode a bit. So let's just have it here. We already have it here. We'll change the pseudocode a bit here. All right. So find all the divisors. So find which string is smaller among string 1 and string 2. If it is of the equal length, choose one randomly. Find the divisor of smaller string. We'll use this logic to find that. Now use the use the divisors of the smaller string to check if they are the divisors of the longer string, and if there are any common divisors, return the longest one, else return the space. We want this answer in Java. So instead of saying use the divisors of the smallest string to check if there are the divisors of longest string, so use the divisor of the smaller string starting from the longest one, and then check if they are the divisors of the longer. If there is any common divisor, return the longest one. Okay, that looks like a good option. So now let's do this. So here we first find the smaller, right? So let's just find the smaller one. Find the smaller string. How do you do that? Just check the length, and the other one is so equal to is considered there. Good. Find the divisors of the smaller one. That logic should remain the same. Now, so here it didn't do exactly what I said because my word was not very specific, you see. So it is just going through the entire set and This is still not good enough, right? We need to know if this value is a divisor for this. To do that, we need to have this logic.